Okay, let's get started. Hi, everybody. Welcome to the webinar. I'm here with my colleagues, David O and Sarah here. This is the webinar for building AI agents with Comet and SageMaker. So let's do a bit of intro to start. My name is Jia, and I'm a principal GenAI and machine learning go-to-market specialist at Amazon Web Services. I'm based out of Dallas and happy to be here. David?
Hi, everyone. My name is David O. I am Senior Worldwide GenAI Specialist, mainly working for SageMaker, as well as a Bedrock adoption and go-to-market strategy. And I'm based in Seattle, and we already have a lot of rain, and it's kind of cold, like early winter. So nice to meet you, everyone.
Hi, everyone. Thanks for joining. I'm Sarah. I'm Technical Product Marketing Manager at Comet. Prior to my role here, I've spent about 5 years working with clients to build AI and ML systems. So I'll be taking you guys through the Comet demo.
With that, let's get started. We've got a pretty packed agenda today. We're going to start by talking a bit about what a typical agent lifecycle looks like, if that lifecycle involves model fine-tuning as well. We're going to do a very brief intro on the Amazon SageMaker AI and talk a bit about why SageMaker is partnering with partner AI apps like Comet. We then are going to be doing a bit of a deep dive on the partnership with Comet, specifically with the two products they have. One is called Experiment Manager, or EM, and the other is OPIC, and describe what the overall value add they have to the agent lifecycle. I'm then going to be handing over to my colleague David, who will be walking you through how to get started with subscribing to these apps from our marketplace and SageMaker. After that, the most important piece of the webinar is the actual demo. We're going to have Sarah showing us how to build, evaluate, and monitor a customer support agent using Comet. We're going to reserve maybe 5 minutes in the end for conclusion and Q&A. However, if you have any questions, feel free to type away on the chat window, and we will be addressing them as we go along. Okay? All right, sounds good. So let's talk about what a typical agent lifecycle looks like with model fine-tuning. As you can see that, a lifecycle like this has multiple stages, different steps, ranging from, choosing a foundation model, fine-tuning the model, and actually building an agent that use that model, evaluating, comparing, tracing the agent before deploying the agent into production, and then monitoring it, after it's been deployed. So it's really involving multiple stages and different personas. It's quite complex. But let's kind of unpack this a little bit, right? You're going to be starting with a data scientist who chooses a foundation model from a model hub. He or she's going to be doing some fine-tuning and model customization on the model. As part of the process, the model metadata and dependencies are being tracked. So whatever they do with model fine-tuning, the model can be reproduced. And after that, evaluation, validation, and have the model registered if the model is performing as expected. So that's the model fine-tuning piece. And from that point on, an application or a software developer is going to continue by building an agentic workflow architecture using the model that has been fine-tuned by the data scientist. As part of that process, one important step is to continuously evaluate the agent, trace the agent, and compare different versions of that agent to make sure that it's performing as expected across, quality, across latency, cost, etc. At that point now, when an agent is doing well and a version is satisfactory, you may move on to the governance officer, where a governance team may be looking at the agent's lineage tracking, understanding how the agent was built, its behavior to make sure that it's safe and it's performing, and approving the agent for deployment. At that stage, a machine learning engineer may take over and deploy both the agent and the model endpoint into production, right, in a consistent and safe way. But the job is not done yet. After that, you want to continue to monitor the agent in production, tracing it, And if performance deviates from norm and you see different user behavior or drift, you want to alert and be able to take actions. So that is the life cycle we want to talk about today and give you a sense of how Comet and SageMaker together can accelerate and streamline this process. Let's quickly take a step back and talk a bit about what is SageMaker AI? What is Amazon SageMaker AI, right? So Amazon SageMaker AI is really a platform that helps customers like yourself build, train, and deploy machine learning models at scale, including GenAI models that are being leveraged by agents. So customers can build foundation models from scratch on SageMaker, but more likely we see customers customizing existing foundation models with methods like fine-tuning, model distillations, etc. SageMaker provides ops abilities so you can create reliable and repeatable workflows, track lineage, track experimentation, basically incorporating your common MLOps practices. You can also improve model governance and make sure that you're able to audit, lineate, and understand the model's behavior and adding the approval process to make sure that every model you deploy is compliant and it's safe. And lastly, managing these models for inferencing, that's a big plus on SageMaker AI, where you can optimize your model endpoints and serve inferences from agents from other requests in a cost-effective way. So that's really what SageMaker AI does. Now the question is, why is SageMaker AI partnering with partner AI apps? There are several reasons, right? But I think the end goal is to be able to accelerate every stage of the agent and the model lifecycle without having a one-size-fits-all solution. So SageMaker AI has curated the industry-leading and best-of-breed tooling like Comet. We are offering choices to our customers, so they don't have to use SageMaker native services. They can choose a combination of SageMaker and partner AI apps tooling. Whichever ways they choose, there is no operational overhead because all the apps are being managed by SageMaker, and there is a much more simplified billing with this approach. And lastly, all the apps are securely integrated with the rest of the SageMaker ecosystem. Now let's talk about why SageMaker and Comet, right? This particular partnership is really important because together we enable best-in-class experiment tracking, agent evaluation, and monitoring to streamline and accelerate the entire agent lifecycle. Number one is Comet is securely managed by SageMaker, and there are two products that Sarah's gonna deep dive more in the demo. One is called the Comet Experiment Manager. This product provides model training, fine-tuning, model registry, and a complete model lineage as part of the process. And then moving on to OPIC, which is the product that provides agent evaluation and optimization for GenAI apps and agentic workflows. Again, customers can choose to use both EM and OPIC and also SageMaker. And together, we believe that this partnership and solution can help our customers reduce development time and improve the model and agent quality in production. So let's go back to the agent lifecycle with model fine-tuning, right? And let's see how this partnership can offer our customers. So you can see where the different services can fit in here in this lifecycle. So a customer can start by choosing a foundation model from a SageMaker model hub. Then a data scientist can leverage either SageMaker or Comet EM to do fine-tuning, to track model dependencies, and to provide model validation and registration. And then we recommend the customer leverage OPIC to actually build the agent themselves, which Sarah's going to walk you through in details later. And then also using agent for evaluation and comparison. Moving on to governance, you can leverage either Comet EM or SageMaker model registry to audit and approve the agent for deployment, and leveraging SageMaker for actual deployment pipelines, and going back to OPIC for the agent monitoring and tracing. So these tools together will give you not only the flexibility, but the breadth of features that you need to manage your agent lifecycle end to end. All right, so with that, I'm going to pause and hand it over to David and talk about how to actually onboard these apps within SageMaker.
Thank you, Gia. I'm going to share my screen. All right. Yeah, I hope that everyone can see my screen. So as Gia mentioned, when customers are running this model and data lineage lifecycle management as well as workflow, they may find a certain point or certain lifecycle stages may need some tools, solutions such as model monitoring, model evaluation, and model testing, and model post-deployment observability. And since there are many tools within SageMaker, within AWS, as well as within even AWS Marketplace, it is very hard for customers and users to select the best of breed tool that is just addressing to his use cases as well as his purposes. And another difficulty or pain points of customers are difficulty in deploying and upgrading and maintaining and scaling the tools in terms of catching up with operations in terms of scale, such as geographical coverage, as well as number of users and different usages evolving, including the recent agent systems support. And most importantly, customers and users are very keenly interested in about securing the data governance as well as security compliances to making sure that no data and no internal proprietary information will be ever leaking into third party or external to his domain or his BPC. And to address all these solutions, as Gia mentioned, AWS and Comet as a partnership together developed this SageMaker Partner AI apps for Comet. And this fulfills customers' needs and customers' pain points addressing solution, such as thoroughly and fully securely managed by SageMaker. As under SageMaker domain, which is working just like a VPC, AWS VPC, to make sure that no data and no model data lineage will be ever leaking to third party or external to customers prem, just like it is being served by self-hosted on-prem or just served by the VPC at AWS. And by having this SageMaker Partner app, Commit application, part of the seamless workflow for SageMaker itself, we are making sure that all the model lifecycle management as well as operation through the CI/CD pipeline from the initial model development, model training, model deployments, and model monitoring after post deployments is all done in one UI and one workflow and workflow as well as a governance tool under the SageMaker capabilities. And another one is seamlessly accessing all this data lineage through the partner app to the model or data that is already residing within the SageMaker. So customer can make it very easy, quick and start for CI/CD pipeline. And everything from the pipeline, it is fully automated and including all the observability and preemptive monitoring of anomaly or any performance degradation, as well as data or model drift. so that user can always do proactive mediation or mitigation of the issue before it is impacting any external or internal customers. And final one is just because this Comet license subscription as well as AWS SageMaker infrastructure billing is all seamlessly combined together for customers' monthly billing. Customer doesn't have to go through a separate billing or separate commercial procurement for partner app or AWS, but all through the one billing through SageMaker. Yeah, with that, as mentioned, the UI that we developed for SageMaker Studio or SageMaker Unified Studio is very seamlessly providing customers capability to discover partner app, including Comet from the Studio UI, as well as deploying it so that the access icon, access button is showing in the Studio UI and can be easily accessed through the Studio UI to the Comet itself for Comet to use as a one button and one click experiences. And with that, I'm going to show a very brief demo about the real SageMaker Studio UI for accessing Comet. So as mentioned, we can quickly configure SageMaker domain for partner access. We can leverage and use existing domain and user role as well. And by opening Studio in the SageMaker, we are directing to Comet button, which is already subscribed and purchased by the user. So I just skipped the intermediate processes for subscribing Comet and deploying it to show here in the Studio UI. But once Comet is deployed, user can easily access this Comet, just like a user is accessing Jupyter Lab or RStudio or Canvas of Studio. So once user press this Comet button, user can enter into Comet. But before that, user can see all the product overview as well as different types of products within Comet, such as OPIC and other NPM like that. So let me yeah. So basically, this is the Comet access UI. Sorry, seems like there is some demo trouble for accessing the Comet here. We normally press additional button here to access to Comet, but I'm going to hand over to Sarah for running all the Comet deep dive demo and walkthrough. Thank you so much.
Thanks, David. All right, I'll go ahead and share and we'll get into the demo. All right, let's get into it. So we're going to be talking about building a customer support agent. So I'll just introduce the use case to get started here. So this is going to be a customer service agent for a fictional electronics e-commerce company. I made it up. It's called Gadget Hub. It is inspired by a real use case, something I worked on with a client about a year ago. So it's somewhat a realistic thing that someone's doing. I simplified it a little bit for the demo. So the idea is that this agent will be able to handle things like, customers reaching out, asking about things like shipping and order status, warranty inquiries, like help troubleshooting their devices, and things like refunds and return questions. The agent should then be able to escalate to a human agent if there's something that comes up that it can't handle or if it's needed. So, it's a fairly common use case. The goal of this would be that the AI agent can completely handle, say, 40% of customer inquiries without having to escalate them, sort of take those really common, kind of repeatable questions off the hands of human agents and let the AI handle that. Um, so, fairly straightforward thing to do, but we do have some constraints that we need to think about. For example, we want to make sure that we are adhering to any company policy that we might have, any like data privacy requirements. We want to make sure that the agent like doesn't offer a crazy discount to somebody, or that our customers' data is not exposed in any kind of risky way. We also want to be able to make sure that we can maintain and improve our customer satisfaction. We don't want like things to get worse when we implement an AI agent here. We want to make sure that our customers are not frustrated or upset by it. And of course, we've got some like cost and latency constraints, right? We want to make sure that this doesn't take too long to respond to a customer. We want to make sure that it's not going to cost a crazy amount. So these are all things that we kind of have to take into account as we're thinking about how we're going to structure the solution for this. Um, and also what metrics we care about. How are we going to measure how well this is performing? These constraints really kind of guide us into what we want to define as the metrics that we actually care about. So getting into kind of the structure of the approach here, we will be building fairly simple, just single agent system that has access to 3 tools. The really key piece here is actually the metrics. So that's kind of why I set that out first. We want to make sure that kind of right off the bat, we're measuring how well this is performing and, able to test that it's actually improving as we work on it. And so I've defined a set of metrics that I'm going to be tracking kind of throughout the process. A couple of them are kind of general metrics. We're looking at hallucination and context precision, making sure that the agent is, relaying accurate information, that it's getting the right information from the context that we're providing it, that it's really, just correct, generally, very basic. We've got a couple that are very use case specific, like our policy adherence. We have one for usefulness to the customer, making sure that it's actually, providing helpful, useful information that the customer would be able to use. And then I've got a couple of agent-specific metrics here. So these are looking at whether the agent is using the tool correctly, right? Is it using the tools when it should, how it should, according to sort of the guidance that I have given it. And then also, is it completing the task, right? Is it actually like finishing the task that it is supposed to complete when it's responding to a customer? And so those are kind of the key piece to think about even before we really start building anything. So in terms of the actual approach, the tech stack, how we're going to build this, my plan for this one was to start with a fine-tuned custom LLM. So a small open source model that I want to fine-tune to really make it specific to my data, my use case. I want to be sure that it's sort of using the data that I've actually collected from human agents. I can really fine-tune it and customize it to that. Use that proprietary data, train it, and I can balance that really good performance then with things like reducing cost and giving myself more security, being able to host this wherever I want to. And then obviously making sure it's, maybe lower latency if it's a smaller model. So those are kind of all considerations that might come into this, deciding to do maybe a fine-tuned model. Wouldn't necessarily be the only way to approach it, but we'll go through that part here. In terms of the rest of the tech stack, I'm going to be using an agent framework to build this. So I used a Google ADK. Really, any agent framework that you prefer, no agent framework works equally as well. Our products, Comet and OPIC, work really well with pretty much anything you'd care to use. Strands agents is great, Crew AI, LangChain, all of those. Other piece we're doing, of course, since we are doing fine tuning, we need to do some model training. We need to be hosting our model somewhere and run inferences in a place that's secure that can handle our customers' private data. And so we're going to do all that on AWS SageMaker. It's a really great tool to use for that. It integrates well with Comet's products as well. And so here you can kind of see, that's the overall plan. We've got a structure for our agent, and we're kind of ready to get started with the process. So here's what it looks like. This is pretty much similar to the process Gia showed you all. We're going to be doing fine-tuning, building agent. Those could happen in parallel. We'll compare performance between them, between different like versions of this with different base models. We'll do some iterative improvement, and then we're going to go into actually monitoring that once it's deployed in production, making sure that it doesn't, go downhill from there, making sure that we can improve on it in the future. So here we go. First piece is fine-tuning. We'll be doing this in Comet's experiment management platform. So that piece is really like that product, experiment management, is really focused on just the model itself, not really the whole agent or AI application. And so that's going to be about that model training process, checking that the model itself is performant, that it's sort of, meeting its performance requirements just in terms of the input and output of the model. We'll move later into OPIC, which is really focused with the entire AI application. So not just the model itself, but the entire system that we're going to build with it. And so with this fine tuning with Comet, what we're going to do is very easy. If you've done any kind of model training or fine tuning, it requires very little actual additional code. You're really just importing that Comet library, setting some environment variables to tell it to actually start logging checkpoints and, uploading that information. We will set up our training configuration and just set it to report to Comet. And then we can just start our training. There isn't a whole lot more you need to add to your code beyond that. So it's not too much extra. As soon as I start that training job, we immediately start logging all that information up to Comet, which is really important when you're doing these kinds of fine-tuning, these long-running training jobs. If anything goes wrong, you want to make sure that you've kind of saved checkpoints, that you've kept track of the data set that you used, everything that you used for that training run. You want it to be reproducible. You want to know what happened, what hyperparameters you used, what data set you used. Make sure that things don't, your data set doesn't leak into whatever you're using to test the model. So a whole bunch of kind of things that are really important to have right as soon as you start training. So I'm going to show a screen recording here of what that looks like once we log into Comet. So we'll go over here. And here you can see we've got kind of the dashboard. So a bunch of this information starts populating as soon as you start training. And then once we have finished the training, some additional metrics can load, whatever you're kind of wanting to track. And so immediately we're tracking code, all of the hyperparameters and training configuration that we used, our system metrics, what environment we need to keep track of, so like the libraries we used. And of course, very importantly, these model and data set assets. So we've got our checkpoints so that we can see, access all of those checkpoints that we use in case something goes wrong, as well as our data set, right? We can track the lineage of the data sets we used for training and evaluation, make sure that things are, being consistent between model runs. And here we can compare between different training runs. So you see, we can kind of see different times I've tried running different fine-tuning experiments, how well did the training go, how are things performing on different metrics. And so here you can see I was comparing between some llama models and this Hugging Face model, small LM. So I compared between those two. I'm sorry, I lost my place in my video, but comparing between those two models, we were able to sort of see, okay, we did pretty well in performance on that small LM model. We didn't do quite as well with the llama model. Things kind of just didn't quite meet the same level. So that's the one I'm going to move forward with. The small LM model, we're going to take that fine-tuned one and then move into it, move into the actual agent development. One second. Can people still see my screen? I lost the setup for it.
Yeah, we can see it.
We can see
Okay,
it.
thanks, guys. All right, perfect. Let me make sure I'm on the right page. Perfect. All right, sorry about that. All right, so we will go right into the actual agent development now. So whether or not you're doing fine-tuning, this is pretty much the same going forward. So building the agent architecture is something we're going to do now with OPIC and with sort of whatever agent framework you're using yourself. And so for kind of the first steps to this is to just start with a really quick prototype, like whatever you can kind of get started with any base model you want to start with, just get something going and start logging that. Start keeping track of every time you run and try with that model. And so we'll kind of go back to this sort of architecture that we've got set up. We're going to start logging this all into OPIC. So that's where we're going to be able to sort of see everything that our agent does and also debug any issues that come up kind of as we're just doing this early prototyping. And so that part is fairly straightforward. Again, with OPIC, we just need to kind of bring in the library and start using a tracer to track every run. So with any agent framework you use, there's an integration. For this case, we used Google ADK, but we've got integrations for pretty much every other framework you might want to use, or even if you're not using a framework, it's fairly easy to set up as well. And so we're just going to start tracing here, and that's all we really need to do. And again, I'm going to take a look at what that looks like once we start logging traces. We're going to immediately start seeing them in the OPIC UI. So here I've set up a project for this. I'm kind of able to see all the errors that have already come up. Starting kind of like when I first started looking at just this base kind of Claude model before I used my fine-tuned one. And I can step into a trace and actually see every step that this agent took when it ran. So I can see the overall architecture, but also the inputs and outputs to the overall agent, the inputs and outputs of the model itself, and also the tool call, the tools that were called, what went into it, what came out of it, how did that all work. And in this setup, I actually had a point where I wanted to debug something. I felt like something was a little off with the agent's response. And so I used our in-platform AI assistant here. And just asked it, okay, what's going on with this trace? Is there something wrong with this? And it identified this hallucinated shipping cost that it kind of came up with. And then I found that in the trace. Okay, so that was a real problem. We need to fix that. So here you can see I just kind of made a comment of it so that later then I can go back, make some updates to my prompt or maybe change the context, make sure there's information that is correct here, and fix that problem before it becomes a bigger one. All right. So that would be, kind of some initial debugging. Basically in that first phase, you're really just trying to get something going and handle kind of the very obvious early errors that start to come up. But the next thing we want to do is actually compare performance. So like, how does this agent that I've built out work if I use a different model? I might use that fine-tuned one that I made to compare it to a Claude model, maybe compare it to just like a kind of basic, like small open source model like a llama model, see how it's performing under these different models. Maybe I want to change my mind about what model to use. And so that again is something we're going to do within OPIC. There's a couple of steps here to follow. One really important thing is that you have a data set. So this is just a set of examples that we want to test this agent on. And the idea is that we want to kind of cover the breadth of all the different use cases that we might expect it to handle, right? So I'd have kind of a bunch of different scenarios. I'd come up with a bunch of different inputs. I'd want to test it on all of those. And so for, this example here, I kind of gave of one of mine. Someone who had dropped their tablet and they broke it and they wanted to know if the warranty would still cover it. And so they're reaching out for that. So that's just one example. I covered kind of all the bases I wanted to. The next part of this, of course, is designing metrics. So I, kind of went through all the metrics that we want to use for this agent at the start. Some of those are just kind of common, like built-in metrics. We actually have them already set up within OPIC. You can just use them right off the bat. That would be like hallucination, context precision, usefulness. And then there are some that are very custom to our use case. For example, this policy adherence. I need it to follow my specific policy, not just any policy, right? So I wrote kind of a custom LLM as judge metric for this, defined really what the policy was I wanted it to be in alignment with. And then we're able to test, well, okay, how well did this agent do in terms of aligning with that policy? The other one that I had to custom define was this agent tool correctness metric. This was more like we do have a built-in metric for it, but I really wanted it to be specific to how I defined my tools, how I wanted them to be used. So I set up a custom metric for this one as well. Something that's like generally a good idea to do, I think, if you really have a specific use case, you also kind of want to have specific metrics to make sure that it's following exactly what you need it to do, not just kind of general stuff. So I got those all set up separately. And then, of course, we can actually run experiments. So we test these, every single one of our examples, and we see how it works on all of these metrics that we've defined. And that is something that we'll see show up then in OPEC. So I'm going to go here to the next one. All right. So here is kind of our experiment dashboard. We can see all of the different tests I've done. So I've run a number of different experiments with different models, different kind of changes to the prompts, things like that. And I'm looking at all of my different metrics. And so here I can kind of group and compare by the different models. Here I'm comparing this Claude model to a Llama model to my fine-tuned small LM model. And I want to see how they work. I can see kind of how much each one of them costs and also how they've done on each of my metrics. And we see here, really like the Claude model is outperforming the others very clearly. It does cost more, and I don't have control of it. I am not self-hosting this one. So there might be some other concerns on the other end of that, but I can compare them all and kind of see, okay, how are they doing? Maybe I can get my fine-tuned model to work a little better or catch up with that Claude model if I do some extra work on it. So that's kind of the next phase is, okay, I can see where my baseline is now. I can see kind of where my models are. I can decide maybe I want to switch to the Claude model. Maybe I want to stay with my small fine-tuned model and try to improve it. It kind of depends on what my, requirements are for my scenario. So now we've got to this iterative improvement stage. So this is the piece where we want to really just try to improve every part of this agent, right? We might improve our prompt, improve, what context we give it, the functions, how they're like either the scheme of the functions or the definitions, anything about that. And then even the agent architecture, in this case, I didn't do much changes on that, but you may decide, okay, I actually want to change the way this is structured. And so we would start doing this iterative phase. And really, like the way that works well to do this is again, kind of go back to those traces that you're logging, see where there might be some like obvious problems that need to be fixed, make some updates, and test again, right? So that's a little bit of a more manual process. We do also have a capability within OPIC to automatically do some of that. So we have some automatic prompt optimization that instead of you having to manually change your prompt, you can tell it what metrics you care about and have OPIC automatically give you a better prompt. So I won't be going through that in detail today, but it is a really cool part of the product, definitely worth exploring if you are having trouble kind of getting your agents up to par. That tool also works pretty well with tool optimization as well. You can actually improve your tool definitions with it. So here we're just kind of trying to iterate and improve. And then at each stage, we want to test again and see, okay, is this doing well? Or am I getting closer? Am I getting worse? What's going on, right? So that phase, we'll see again with an OPIC. I'm actually just going to go back to kind of the after phase now that I've made a few changes to my prompt and see where we kind of have run this a few times. We've updated the prompt. I've actually added some more context in this case. We can see if things are actually improving here. So here again, I can look at sort of all my different models, how things are performing. I did some more testing with this small M model and I've added some different prompts. We can compare them now a little bit more easily. And we can see here the small LM with the prompt update that I made, it did reduce its hallucination. So for the hallucination score, we kind of want the score to be low, not high. So we're seeing like less hallucination, and then the other metrics are doing better. We're seeing better policy adherence after I updated the prompt. Especially comparing between those two, we can see that the new prompt that I added, we've actually got better performance, and we're actually right on par now with this Claude model. So we've got this much smaller, much cheaper, self-hostable model now on par with, this very fancy Claude model in terms of performance. So that's great. That's kind of what the goal was as I was trying to build this. We're able to get there through just making these, updates and changes to the prompts, improving the way that we handle the data. All right. So once we kind of get to the point where we feel like we are all set, we've got things working the way we want them to, we're very, confident that our evaluation metrics are doing well, we're ready to deploy this model. The next phase is we want to actually be able to monitor this continuously. We don't want to just throw it out and hope for the best, right? We want to see, okay, well, does this work for real users? Is it working well in production? And we want to know if there's something that we need to change. Also, really importantly, we want to be able to gather data that we can then use to make this better. Maybe I want to expand the capabilities at some point, make it be able to handle more, scenarios for customers. And so being able to sort of gather data from production is a huge part of that. It will help us be able to, build upon this and deal with problems that might come up in the future. And so that's all stuff that we can do as well within OPIC. We don't need to actually add any extra code. All of the things that I added for observability to be able to start tracing each run will work just as well in production. And so we can actually just start tracing millions, billions, however many traces there are, all in OPIC, and we'll be able to see kind of anything that went wrong within that. So I'm going to go back into the UI one more time and show you guys kind of what that looks like once we're at that point where we're actually tracing, we're, keeping track of data in production. So here again, we can see like all of my traces. I only had a few hundred here, but you could realistically have, millions. So in this case, we're tracking everything. We might set up some online evaluation metrics. So these are the same metrics I was interested in tracking originally. I can set them to only evaluate at a certain sample rate. I did 100% here, but for a real case, you probably only want to do a smaller percent just to, not have to run that many LLMs. And so here we can kind of see all that data in production live as it comes, keep track of how many tokens we're using, our costs, and of course, very importantly, the metrics. So if we look at this scenario here, I was specifically tracking this outcome metric that I had mentioned earlier, right? We want to see like, okay, are we able to see, well, did the agent actually complete this task on its own? Did it answer the question correctly? Or did it have to hand off to a human agent? So I can track that also here just by setting it up, adding sort of that code to log it from my application. And now I can tell, well, okay, if we're seeing kind of which cases were escalated and which ones were not, I can use that then to iterate on my agent, make it able to handle more scenarios on its own. So that's sort of the process by which we might improve this. We might tag some cases if there are traces that are looking bad or got some bad user feedback to know what we might need to use to make changes in the future. So that is,
Sarah,
oh, yes.
sorry, could you click try Gemini button because the audience asked that is a little bit distracting.
Oh, I'm sorry. I
Thank you
didn't
so much.
that.
Thank you.
Yeah, of course. No worries. All right. That is actually the conclusion of the demo. I do want to see if there are questions. I've been sharing my screen, so I was not able to see them, but
Yeah,
I
Sarah, I
can.
think there was one question that I think you can help address. It's around monitoring cost with agent deployments. Obviously, there's token cost, but there's other costs as well with infrastructure, with agent framework, etc. I think OPIC is a great place to track all that cost. Can you talk a bit about that?
Yeah, actually, I need to think about it a second. Yeah, I think like it's mostly designed to track like your specific, LLM call costs. You can actually customize the way that you log costs. So I think like it would be a little bit of like custom setup to do that, but it's certainly doable. You would kind of customize the way like you would have to know kind of like roughly, okay, how much is my, infrastructure cost, if you have like a way to, I guess, estimate that per trace or per token, you'd be able to add that in. There isn't like a way that it's like directly monitoring like the usage, so that would be a little bit of a manual process. But
Tagging the resources, right? Tagging the resources and be able to track them.
sorry, can you say that again?
Like tagging the resources and be able to track them in OPIC.
Yeah, I think what you would do is like probably set up like a specific, like kind of a custom function to like add that. You can always add metadata into it, right? So like you can always add the specific data that you want to track in addition to whatever, is automatically logged, essentially. So it's kind of infinitely customizable. But some things are automatically logged, other pieces you might need to add manually.
The question on why joint inference output cost is more expensive than input token cost. I don't think I think the question is more on tracking the cost during inference. Obviously,
Oh yeah.
the token cost can happen on both input and output of the model.
Yep.
It's not necessarily one way or the other is more expensive, more like the inferencing cost on its own. But remember that there's also training cost also, right? I mean, there is when you're doing fine tuning, if you're fine tuning models, there is a cost with actual fine tuning as well. So.
Yeah,
Um,
yeah, that's an important one. I was thinking about adding actually a thing on that, and I decided not to. But yeah, that would be something you would definitely want to, think about probably before even starting, right? Do I need to fine tune? Is it worth doing, or can I get there just by, updating my prompts, right?
yeah. Yeah, we see a lot of customers. Actually, there's a question asked to the host and panelists directly from an audience. Why should we even fine tune when they're off the shelf models like Claude and GPT, right? I mean, I don't know, Sarah, if you want to talk a bit more about your experience seeing with your customers, who in what scenario they would like to fine tune their models, paying the extra cost but getting better performance and less hallucination.
Yeah, yeah, for sure. I mean, I think there's a lot of scenarios where you don't need to fine tune. Like it is not easy and it does like also cost money. So I think like, it's something that you want to think about before you do. But I have worked with a number of customers that have decided to fine tune because of, you know, either very domain specific kind of data that they're working or like use case that they're working with. Like if there's something that's really specific to them and it's hard for them to get a general model to do well on it, sometimes they might want to fine tune. Even sometimes with those cases, RAG doesn't even really work that well. So I've seen it happen a lot with that kind of thing. I've actually seen people a little bit separate. I've seen people actually make custom embedding models, so they might fine tune an embedding model. Um, if they want to like optimize their retrieval for RAG. So there's a couple of scenarios where you might decide that you really need good performance on something that's really domain specific. And you might also have those other constraints I mentioned, right? Like security. You might like want to make sure that it is a model that you can self-host, that you have full control over. If you're calling a GPT or, an OpenAI API, you don't actually have control over that model. So they might actually make updates that you don't know about. And that can sometimes be an issue if you have a really kind of touchy use case. So there's that. There's, of course, cost and latency. If you're really cost sensitive, you might decide that that inference cost is really high for you. And so if that inference cost is much higher than the training cost would be to fine tune, you might care a lot about having a small model that you can self-host, especially in those domain specific areas.
I
But
think latency definitely is one factor we see quite a bit as well. If you back all of the agents with one big model like Claude, I mean there's going to be latencies down the road, right? If everybody's calling it. Whereas you
yeah,
customize, smaller models, you can serve your agents better.
yeah,
Um,
100%.
that
Especially
was
actually in
that's
multi-agent systems as well. If you are building a complex multi-agent system, you're making a lot of LLM calls that can really hurt your latency.
absolutely. Another question, what type of fine-tuning does the framework support? Is it supervised fine-tuning or does it support examples of low-ranking adapters? I think
Yeah.
it's general, right? I mean, it supports all of it. It doesn't really have any restrictions on the framework. Same thing with SageMaker as well. Yeah.
Yep.
Mhm.
Yeah, yeah. Basically, any kind of model training that you're doing, you can log with Comet EM pretty easily. So yeah, I actually did use I used LoRa fine tuning with with this case. So yeah, you can definitely do that.
Yeah. Um, that's all the questions that I see from the chat window right now. Does anybody have any other questions that you want to raise to on the call? You can just type away on the in the chat window. Yeah, I think that's all the questions. Any conclusions, closing remarks from Sarah and David? You guys want to talk about?
Yeah, I mean, I can always have a final remark, but I think for me, like what I've learned, especially with Gen AI, is really just the importance of testing. Like evaluation is key. Anyone can get a prototype going, but getting that reliability in production, it's not about the specific framework or, whether you're fine-tuning or not, or really anything else. It's about being able to evaluate and then having that good infrastructure, right? Like if you're hosting on SageMaker, you're doing all this in a place where it's really well supported and you're doing kind of that boring base work really well. I think that's what makes things work really reliably.
Yeah. I think my final remark is I really see ops and governance as really important. Folks can build an agent and see it working in their notebooks in the VS Code, but to actually deploy it with guardrails, deploy it with thorough evaluation, testing, making sure it's going to add value to the business, require really a workflow that is well defined with very good best practices. So definitely think about things like experiment tracking, think about evaluation, testing, post-deployment monitoring, all of that need to work together, to make sure your agents are just not doing well from your local environment, but can work in production. So tools like SageMaker, tools like Comet, experiment management and OPIC are there to help you, accelerate that process and govern that process as well. Yep.
100%.
Yeah,
Yeah,
we have
I think
one more last question in the chat.
There was a question on for the demos use case, fine-tuning the smaller model. What was the overall cost of fine-tuning and model improvement?
overall cost. So I didn't fine tune the model to like a fully like production level rate. So I like actually did it locally. So I actually don't have like a cost number I can give you on it. But yeah, it was if I were to do that in like a real use case scenario, I would have trained it on a lot more fine tuning data. I trained it on like a very small data set, more for the, looking at it within Comet EM. So I would say like, yeah, it probably wouldn't be a helpful number even if I had it. But yeah, it'll depend on the model you're using and how large your, fine-tuning data set is and where you're doing it. I don't know, Gia, I know you guys like, I'm sure people are
Yeah,
using SageMaker for fine-tuning jobs. Do you
yeah,
have
there are
any?
different kinds. Yeah, there are different kinds of fine-tuning, and you can do full fine-tuning, right? Full-fledged fine-tuning, which is you're changing all the weights of the model, which requires a lot more data set to fine-tune and to evaluate. That obviously going to come at a much higher cost than building, let's say, a LoRa adapter that just changing, that just putting the adapter on top of the base model. With that approach, you're going to be getting lower cost comparing to a full fine-tuning. But at the end, but then that's going to be more expensive than doing prompting, right? So you have to do different experimentation and compare the output based on your use case. Having experiment tracking with Comet or with SageMaker, you get to have that kind of playground and be able to compare these different approaches and see which one is most cost effective and performing for you.
Awesome.
Okay, great. I think with that, we can conclude the call. Again, thanks everyone for participating. By the way, somebody was asking whether we can share the slide deck. We can talk offline and see if we can. We'll send it out to the participants. And yeah, any questions, feel free to let us know and reach out, and we'll be happy to talk. Yeah, great.
Everyone.
Thank you
Thank
so
you,
much,
everybody.
everyone.
Thank you. Bye-bye.
Let's keep in touch.
Bye.
Thanks.
Thank you.